This is a hot mess. Welcome. We will be going over the test stuff related to Chapter 8, which is the reaction types and aqueous chemistry. Just a heads up. So I've prepared the test. All I need to do is double check it, make sure everything will work smoothly, and I'll send it out. This test will be sent out in 2 separate parts. Test part 1 is going to be 9 questions, all file uploads. So any questions relating to Lewis structures where you actually have to draw it, any ones where you actually have to write a chemical formula, a chemical reaction of any type. So there'll be 9 questions. There'll be like there's one, balance this equation and finish it out. There's like 4 net ionic reaction equations. And there is like maybe, I think 4 Lewis structure questions. So with that in mind, all of those, you will take a picture of you'll draw on a separate sheet of paper, take a picture and upload. But those are 9 questions, the first 9 questions of the test. That'll be set in part 1. I'll give you like an hour and a half to do that, mainly because I imagine an hour and a half will be suitable for how annoying it might be to upload that stuff. Now, part 2 would be questions 10 through 25, and the bonus is all multiple choice, checkbox, drop down, something like that. There is 2 short answer questions that I'll have to grade by hand, but most of it will be there's only one right answer, and it's pretty hard to screw it up. I mean, if you know what you're doing. It's not like last time where if you I wanted you to put 122 and you put 122 millimeters, it would mark it wrong because it didn't know. You didn't know I didn't want you to include the units. So I have to double check, make sure that all looks right, make sure that all is right before I send it out. But that should be sent out maybe later today, assuming my computer doesn't implode. Worst case scenario, though, that is all loaded online, so I could probably rescue that. Not that that's necessarily good for you. I see my screen seems to have frozen. Okay. That's super important. Okay, moving on. Oh, let's see, what is it for? Number. Yeah. Okay, we're gonna work through this best I can. I'm not sure if this is necessarily going to look as good as I hope it's going to look on the screen, but we'll do what we can do. This is best I can do on short notice with my computer being as belligerent as it is. Okay, so I'm going to skip through the ones that obviously don't apply. This test may be actually the test here that I gave that year might be a little bit harder than the one I'm going to give this year, mainly because there's a little bit more questions this year, so I'm making the questions a little bit easier. However, we still got a lot of material, including Lewis structures and all that. Okay, starting with number 1. It's an oxidation reduction reaction. Which of the following reactions, what element is the reducing agent? So this is one step harder than what I'm going to ask you on the test. What is a reducing agent? The reducing agent is the atom that is oxidized. And I'm going to even tell you, what does it mean to be oxidized? The guy that is oxidized is the guy that loses electrons. So our job here is to figure out what is lost and what loses electrons, what gains electrons. I'm going to see if I can physically draw on here. That'd be great. Okay, let's see if this will work. No, okay, that's not. No. Pen. Let's see if this will work. Oh, good Lord. I got my mouse back. Hooray. Okay, well, that didn't work. Either way. Reject. Okay. Reject. I don't know how I managed to do that, but okay. Okay, so with that in mind, which of these elements are oxidized? So how do we find oxidation? We need to be able to determine the oxidation state of each element and look at which guy is losing an electron. The simple thing, sodium and iodide. Sodium is +1, iodide is -1. Fluorine, being a element, is 0. Iodine is 0, and sodium fluoride would be +1 and -1, respectively. So fluorine is going from 0 to -1, and iodide is going from -1 to 0. So when you lose an electron, you become more positive, or at least less negative. And hopefully we can see that 0 is less negative than -1. So iodide is the element that is being oxidized, and thus it is the reducing agent. Skipping 2, skipping 3, skipping 4, skipping 5. Balance this following equation. So for here, we need to be able to balance the carbon, the hydrogen, and the oxygen. Typically, in a combustion reaction, you want to balance the carbon and the hydrogen first, and then the oxygen last. But we have to take into account all parts. So, working this onto the board. C12H. H22 O11 plus O2 goes to some amount of CO2, some amount of H2O. All combustion reactions between carbon, hydrogen, and oxygen will yield these products. All combustion reactions between carbon, hydrogen, and oxygen will yield these products. So with that in mind, 12 carbons, the easiest way to balance that would be to put 12. 22 hydrogens. So because there's 2 hydrogens per water, you would have to have 11. Now here's where it could be a sticky wicket, because you will have an odd number of oxygens on the right. 12 times 2 is 24. 11 times 1 is 11. But just so fortunately, there's already 11 oxygens accounted for in the structure. So we need to balance 24 with the 2 oxygens. So half of that would be 12. 12 times 2 is 24 plus 11. Would the oxygens on the right would equal the oxygens on the left. Now you could leave that blank, or you could put a 1 there. However you seem to want to balance this is acceptable. Oh, I know, I want to put 4. Now, looking at these guys, expect something like this. I've actually split this a question like this into 4 separate 1-point parts, because there's no way to put multiple blanks on the same question and make this work out. But expect on classify the following as a combination, a decomposition, a single displacement, a double displacement, or combustion. So breaking down what each one is. Combination is two elements become one element or one compound. Decomposition, one compound becomes 2 compounds or elements. Single displacement, an element and a compound switch places. So an element goes into a compound, kicks out a new element. Double displacement, 2 compounds, the cations or the anions, switch places. And combustion, well, essentially, it's like a single displacement with oxygen. So looking at here, we have ammonium nitrate plus yields laughing gas, N2O, and water. One compound breaks down into 2 things. This would be decomposition. Here, zinc plus HCl goes to zinc chloride and H2. So we have zinc, a pure element, and HCl, a compound. The zinc and the H switch places. So the zinc goes into the compound, and the H gets kicked out as an elemental gas. So that's single displacement. Silver plus chlorine becomes silver chloride. That's a combination. 2 elements become 1 compound. This is probably the trickiest one. C6H5OH plus lithium hydroxide, you switch places. The H from here and the Li from there switch places to form water. To form lithium C6H5O and H2O. So this is really HOH. But this is a double displacement. Then finally, sodium plus H2O goes to sodium hydroxide and H2. Once again, a single displacement. The Na replaces one of the H's, just like in this equation. Just like in this equation, the Na replaces one of the H's, and so you have H2 as a byproduct. So I just want to see something. Okay. Okay. Skipping 8, skipping 9, 10. Number 10, write the net ionic equation of this. Write the net ionic equation of this. Let's see what this looks like. Okay. So what we have here is iron. Well, I might as well do this if that's going to be that. We have iron chloride, potassium sulfide, goes to iron sulfide and potassium chloride. So what we would have to do in this type of equation. If the products are not given, you have to determine, if I just gave you like this and say, what is formed? Literally, what is formed is they swap places. Most of those net ionic equations start with a double displacement. If you can't do a double displacement, well, we need to work on that first. But so double displacement means we're going to swap. This pair is going to go there, and this pair is going to go there. So the byproduct is our KCl. There's two of them. And FeS. So that's our starting point. The second point is double check solubilities. I have included the table in this. I've included the solubility table in this. So look at the solubility table, look, cross-reference iron and sulfur and say, is this soluble? Potassium and chloride, is this soluble? And what you find out, that's aqueous, that's solid. And so what does that mean? When we break this down into net ions, you have Fe2+, 2Cl- plus 2K+, plus S2- goes to FeS solid and 2K plus and 2Cl-. For the net ionic equation, we then cancel out everything that is identical on both sides. 2Cl- cancels 2Cl-. 2K plus cancels with 2K plus. The final resulting answer is Fe2 plus S2- aqueous goes to FeS solid. That would be your answer. You would say, that would be what you would write on your paper and take a picture of and upload. Fe2 plus and S2- aqueous goes to FeS solid. And how do you know that's a solid? You look at the table. What you have to do is look at the table, and you should be able to cross-reference whether that's solid or not. Okay. Just want to make sure. Okay. Okay, that's good. Okay, with that in mind. Skipping 11, skipping 12. Expected question like 13. Maybe not quite as pretty nice as this chart, but one where activity series. So when you're working with a solution, every metal above that will react with the metal in the solution. This is something we will actually do in lab today and tomorrow. We will mix metals with metal solutions and try to see which ones react. We will mix them together and see, did something form on the metal? And based on the activity series, certain things should react, certain things should not react. So anything that is above lead on this table will react with lead. So magnesium is right here. Magnesium would react. Magnesium is right here, the top of the green section, would react with lead. Iron, it's the bottom of the green section, but it's still above lead. So it'd react with lead. Zinc, it's in the middle of the green section, would still react with lead. Copper, which is below lead, below hydrogen even, will not react with lead. So only answers 1, 2, and 3. So answer C would react with lead. But I could have said, if I had chromium nitrate, how would my answers have changed? Chromium is right here. So if I had chromium, Magnesium would react with chromium nitrate. Zinc would have reacted with chromium nitrate, but iron would not, because iron would be below chromium. If I gave you calcium nitrate, calcium would not have reacted with any of them, because calcium is above magnesium, iron, copper, etc. But so that is an easy thing to do if you understand it. I'm not trying to make it hard. I have just a big table of ions, the one that you can find in the Achieve. Just a big table of ions attached with that problem. You look on there, you see what element is above the solution. Okay, net ionic equation. Net ionic equation. This is an acid-base one. This is an acid-base one. Nitric acid plus barium hydroxide goes to water and barium nitrate. So, this in mind. Same thing. Any acid-base reaction will result in water and the salt. So if I just gave you nitric acid, aqueous, and barium hydroxide, aqueous, the net effect is a double displacement. H and OH. You form two waters and a salt. The water is a pure liquid. Much like a pure solid, we do not break apart the pure liquid when we do the net ionic equation. Now, keep in mind, only strong acids will break apart in the net ionic. Only strong acids. Strong acids such as nitric acid, sulfuric acid, HCl, HBr, HI, and HClO4. Only those guys are considered strong acids that you need to worry about. So when you write the net ionic, strong acids like that will break apart. 2H plus, 2NO3 minus. If it's a weak acid, like HCN, HCN is weak, it would stay together. There's an example on the Achieve homework of that. Speaking of Achieve, I've changed the grading protocols. So you should have got a bunch of, well, at least most people got between a half and like 2 to 3 percentage points back, because I penalized you less. I meant to penalize you less for each wrong answer. And now I think it should, please double check and get back to me, should allow you to go back and turn in assignments late. I've been saying it should have been, and it should have been able to turn in assignments late, but now you should be able to turn in the assessment assignments late. It wasn't set up before. So, and BA 2 plus and 2NO3 minus. So what we see, NO3 minus, NO3 minus, Ba2 plus, Ba2 plus. So my net ionic equation, you could say 2H plus, aqueous, plus 2OH minus, aqueous, goes to 2H2O, liquid. With that in mind, you could even simplify it by dividing everything by 1, everything by 2, making it H plus OH minus goes to H2O. But since I'll be hand grading it either way, I will accept either answer. If you were to do this one on the on the homework, I think it'd probably want you to do H plus OH minus H2O instead of 2, 2, and 2. But I will not be marking off. Okay. Balancing the following equation. You could balance the iron first, but you'll have to go back and rebalance it. What you see, if I double the iron, but then, okay, I have 3 oxygens and 2 oxygens. So what do I have to do? I have to double the iron oxide. So doubling the iron oxide would be 6 oxygens here. So I'd put 3 oxygens there. And so because I doubled the iron oxide, I'd have 4, 3, and 2. But balancing the chemical equation should not be something that should be tricky. And I do not have very many balance the chemical equation questions. So I have one of number 18, just one, but be able to do that. Determine what is the charge of the underlined element in the following compound. So the rules are, remember, H is typically +1. O is typically 2-. Pure elements are 0. And halogens are usually, not always, but usually 1-. So what we have here, H plus is 1, O is 2-. Because there is 4 2-, that means it's -8. -8 plus 1 is -7. The overall charge of this whole compound is 0. So chlorine has to be +7. 1 plus 7 is 8, minus 8 is 0. OH minus, this whole thing is -1 because 2- and 1+ is -1. There's 3 OH minuses. So -3 will have to be countered by +3. But then again, we knew this from chapter 2 when we said aluminum is almost always 3+. Tin. There's 2 oxygens. Each oxygen is -2. So -4 must be countered by tin's +4. What is going on? Boron. Boron has 3 chlorides. Each chloride is typically 1-, is usually 1-. So boron has to be +3. It's not a coincidence that boron and aluminum are right above each other in the periodic table. Finally, sulfur. That's pure sulfur. That's sulfur by itself. Even though it's S8, it's just sulfur. There's no other elements. Because there's no other elements, it has to be 0. There's no other elements in that. It's not a compound. It's a pure element. Expect one like number 19. Number 19, classify the following reaction as salt metathesis, acid base, or oxidation reduction. So to do this, remember, you can classify these based on some simple facts. Precipitation or salt metathesis is a solid forms from a solution. Acid base is a H and a OH come together to form water. If you see an H and OH and water, you know it's acid base. Oxidation reduction is electrons are transferred. The easiest way to spot this, and it's not always true, but the easiest way is looking for a pure element being formed or a pure element being used up. Why? Because a pure element is always 0. And if an element is absorbed into a compound, it has gone from 0 to something not 0. Anytime you go to something not 0, you have to have lost electrons or gained electrons. So if you can ever see that, that will be an easy answer. Not all of them will be easy, but if you can do that, that will give you an easy answer. So how I would typically do is I would look acid-base first. Then I'd see, is there a pure element to eliminate at least an obvious redox? And then I have to look at, is any compound in the product a solid? I would almost always do the precipitation last because the precipitation can be a tricky one. Double check that any of these are a solid. If none of these are a solid, you may want to double check your redox one or rethink them. But so I'll look here. Okay, there's no H plus being lost. There's no water being formed, so it's not acid base. There's no pure elements being consumed or pure elements being formed, so it's not obviously a redox. So now I want to look, is any of these a solid? I can cross-reference iron and carbonate on the table and say iron carbonate is a solid. Ammonium sulfate is not, but iron carbonate would be a solid. So this one falls into salt metathesis. The second one, potassium chlorate goes to potassium chloride and oxygen. I don't see any water, but I do see a pure element being formed. I see O2. So I know without a doubt that this is a redox reaction or oxidation reduction reaction. So I can nab that one right away. Number 3, sodium hydroxide and phosphoric acid goes to water and sodium phosphate. Well, that kind of makes it a little bit easier. OH and H come together to form water. So clearly an acid base. Aluminum plus iron oxide forms iron and aluminum oxide. I've used this example multiple times in class. It's the thermite reaction. We have a pure element being consumed and a pure element being formed. A clear example of redox reaction. And finally, mercury plus sodium chloride forms sodium nitrate and mercury chloride. Mercury 1 chloride to be specific. You look, there's no water being formed. There's no pure elements being produced. Now I want to check, are any of these an obvious solid? I'm going to cross-reference mercury 1 with chloride, and I say mercury chloride, that is actually a solid. That would be insoluble salt. And so it's salt metathesis. It's a precipitation reaction. But if that wasn't, I would double check that. And that's what we'd have. So with that in mind, the answer for this one was salt metathesis, redox, acid base, redox, salt metathesis. And that was those questions. And just a heads up, next week is the week of Mole Day. Mole Day is the chemistry holiday, the only chemistry holiday we have, 1023. It is the named after Avogadro's number, 6.02 times 10 to the 23rd. The chemistry club is planning to do some demos all this week, so stop by the Velo. May see some cool stuff. Try to blow some stuff up or make some slime or do something fun. But either way, that's coming up just this next week. But okay. That is the test. That is the test. We don't really have that much time to continue, mainly because we started so late. But so that is the good majority of the types of questions you will see on this test. Between these two videos, we have being able to draw Lewis structures, being able to determine polarity or not of Lewis structures or Vesper models, being able to determine electronic geometry and molecular geometry, being able to figure out hybridization, being able to figure out sigma and pi bonds, being able to do net ionic equations of both acid-base scenarios and salt metathesis scenarios, being able to classify reactions of both either combination, decomposition, single displacement, double displacement, what have you, or acid-base, redox, and salt metathesis, being able to balance some chemical equations, and being able to answer some questions about what like activity series and oxidation states. So that's essentially a good deal of what's on the test. Remember, I'm going to send out the test in 2 parts. Part 1 would be the fill out the 9 questions, which we fill out the file. You take a picture of your answer and you submit it onto the test itself. You add it as an attachment. And part 2 is all the multiple choice checkmark ones, fill in the blank type things. But so I'll hopefully send that out later today. In the meantime, I'll see you guys in lab. Don't forget to finish up your Lewis structure lab. Like to be able to give you some feedback on that. In the meantime, have a good day.